Hello everyone, we have a chemistry question here under grade 12 Zapier syllabus. So the question reads, a sample of 0.03 grams of small pieces of magnesium was added to 20 cubic centimeters of 0.10 mole per cubic decimeter of hydrochloric acid. The two reacted according to the equation below. Magnesium solid plus hydrochloric acid to produce magnesium chloride plus hydrogen gas. So as you can see, the equation is already balanced. The equation is also showing us that 1 mole of magnesium required 2 moles of hydrochloric acid to produce what has been produced outside, which is magnesium chloride and hydrogen gas. Question 1, write the word equation for the above reaction. Question 2, what is the chemical test for hydrogen gas? Question B1, calculate the mass of magnesium which was in excess. Question B2, calculate the volume of hydrogen that would be produced at RTP. So we start with the first question. Write the word equation for the above reaction. So we have been taught that we have, this is A1, magnesium plus hydrochloric acid produced magnesium chloride and hydrogen gas. So that is the answer to question A1. So we can see here we have magnesium plus hydrochloric acid to produce magnesium chloride and hydrogen. So that is now in weights, which is the written form. The next question which we have here is saying A2, what is the chemical test for hydrogen gas? So chemical test for hydrogen gas. Remember we have got 2 syllabi for chemistry, we have got pure and non-pure. So for the pure, you need to write the test as well as the observation or the result. But for those under just science, you just need to write the result, which is going to be treated as a test. So for the test, you can say bring the lead of Fleming, the lead splint to the mouth of jar or test tube containing the gas supposed to be hydrogen. Result, if the lead spread is put out with a pop sound, then the gas is hydrogen. So that is the case there. Bring the lead splint to the mouth of jar or test tube containing the gas supposed to be hydrogen. That is the test. You're testing. What is your observation or result? If the lead splint is put out with a pop sound, then the gas is hydrogen. So that is the case for question A1 and 2. We go to B1. B1 is saying calculate the mass of magnesium which was in excess. So if we go back to our question there, a sample of 0.03 grams of pieces of magnesium was added to 20 cubic centimeters of 0.1 mole per cubic decimeter of hydrochloric acid. So that is the case there. So what we are going to do, we have got both reactants, which is magnesium and hydrochloric acid. Then we need to know which one was in excess and which one was not in excess. So the one which is not in excess is called the limiting reagent or reactant. It is the one which finishes first in the reaction. It is the one which tells you how far the reaction will go. So that is what we call a limiting reagent. So the one which is going to have less moles than the friend, in short, not less moles than the friend, but less than the required moles, is called a limiting. It's like they both have moles, but how many does the friend require for the reaction to complete? If you're going to have less, then you're going to be a limiting reagent. So a limiting reagent is the one which is a reactant which gets used up first or fast in the reaction and determines how far the reaction will go. So the first step, we find moles for both the reactants. So reactants which we have magnesium. So this is our first reactant. Let's calculate the moles. Moles of magnesium. We're going to say mass over relative atomic mass, since it's just alone. So according to the data we have, the mass present is 0.03 grams. The relative atomic mass is 24 grams per mole. Then the number of moles is given by this formula. Others, they use molar mass, it's the same. But if you're considering one substance or one element, it's better to use AR instead of MR. But it's just the same. Okay, we're going to talk about the same thing. Okay, so the mass present is 0.03. And the relative atomic mass, according to the periodic table, it's 24. So remember, we're calculating moles. So using our calculator, we are saying 0.03 divided by 24. According to the answer, we have got 0.00125. So we are saying we're getting 0.00125 moles for magnesium. Now let's calculate for hydrochloric acid. Considering hydrochloric acid, from the data which we have volume given as 20 cubic centimeters, and then we have got concentration, which is given as 0.10 more per cubic decimeter. So from this, it's clear this guy has to be changed to decimeters by dividing by 1,000. So volume now changes to 20 divided by that one, which is 0.02. Just to confirm, we are saying 20 divided by 1,000, which is giving us 0.02, just as we assumed. Okay, from this point, we are now able to find the moles. We know that concentration, number of moles equals concentration times volume. That is the equation. We have concentration as 0.10 times the volume 0.02. Okay. From there, we can use our calculator to say 0.1 times let's calculate. I always say 0.0. Okay, 0.10 times 0.02. So from there we are getting that answer, which is 0.002 moles. So moles present. That is, when I say moles present, are the ones which are just there, like you have been given maybe money to buy something. So this is the money present. But what money does the owner of the shop where I've gone to buy require? That is now where I'm going to going to do the excess one. So the moles for magnesium which are present according to our calculation is 0.0125. The moles for hydrochloric acid which are present, it's 0.002 according to the calculator there. Yeah. Now let's go to the equation. We go back to the equation. Magnesium plus 2 hydrochloric acid aqueous. This is, we just need these two. We are not interested in the results. So here, let's check. We have the moles for the two guys. Let's we can see that magnesium is having less. Yes, there it's less. This one is having more, but that's not a problem. We can't determine the excess from there. No, we can't. We need to determine it from the equation. So now, since this guy has more, this one has less, we check for next step, which is saying how many does hydrochloric acid need from the present? These are the ones which you have. But how many should you donate in the equation for the equation to go on? So we say moles, moles of magnesium over moles of hydrochloric acid. How are they balancing in the equation? Magnesium was 1. Then hydrochloric acid has 2 in the equation. So now, how many moles does hydrochloric acid need for magnesium? So we are calculating moles for who? For magnesium. So moles of magnesium required. So from here, make magnesium the subject. What are we doing? We have the moles present. You have been given money. And then how much does the thing cost? That is what we're trying to look at. So if you're going to remain with some money after buying, then that money is in excess. Clear? Then if your money will be insufficient, then you are a limiting reagent, because you have gone to buy something which is more than the price. So that is the case. We want to know how much hydrochloric acid require from these moles of hydrogen, magnesium which are present. We want to know how much does hydrochloric acid need. So this one times that one, we still get moles of hydrochloric acid, then over 2. So we have just made magnesium the subject, because we want to know how many are required from the present. So let's now check how many moles of these ones are present. 0. Like that, divided by 2. Then after division, this one is simple. We can forget about the calculator at the moment. So these are the moles. So from whatever is available, according to the equation, hydrochloric acid just needs 0.001 of what? Magnesium. So now check, how many do we have for magnesium? 0.00125. But we just need 0.002 0.001, meaning magnesium is in excess because it has more than needed. That is the idea. So now we have known that it is in excess. So they are variable. So how many moles are in excess? Moles of magnesium in excess. Yari mu excess. We are going to say present moles minus required what? Moles. So how many are present? We have 0.0125. 0.00125. Then how many are required? 0.001. From our calculation there, we can see 0, 0, 0, and here there will also be a 0, and then a 25 will remain moles. So these are the ones which are in excess. Now that we have known the moles in excess, we can now calculate the mass of the excess magnesium. Mass of excess magnesium. How do you calculate mass? Number of moles times the relative atomic mass. So number of moles, it's 0.00025 times 24. So now we can check, just to check. It's always important. 1, 2, 3. 1, 2, 3. Okay, we are safe. Now we can use the calculator to say 0.00025 times 24. So that is our answer. We can check the answer there. 0.006. 0.006 grams. So those are that is the mass of magnesium, which is in what? Excess. Just to run you through, when you are calculating excess, first calculate their variable. So we calculated the variable moles of magnesium. We also calculated the variable moles of what? Hydrochloric acid. So we found that these are the variable or present. Thereafter, go to the equation. Pick the one having a large number. And then calculate for the other one which is having less. So magnesium over hydrochloric acid, according to the equation, magnesium is balanced by 1. That's why we have put a 1 there. Hydrochloric acid is balanced by a 2. That's why we have put a 2 there. From there, we make the one we want to calculate the subject. The smaller one, and then we already have the moles. So it's simple for the other one. We put the moles on top. For the one we have, which is a big number, balanced by a big number, and then we just calculate. After that, you can check that the available or the present for magnesium and the required. The required is less than the present, meaning to be in excess. From there, it is simple. You just subtract present minus required, and then we have that case. Okay, let's go to the last question, which is saying calculate the volume of hydrogen that would be produced at RTP, room temperature and pressure. So the volume, okay, B2. Volume at RTP is calculated by, say, number of moles times the molar volume. At RTP, we know that molar volume, it's equal to 24 cubic decimeters per mole. That is at RTP. So how many moles, in short, how many moles do you have for hydrogen? Multiply them by the molar volume. Since for each mole it's 24, how many moles do you have? So the question is just about moles here now. Let's go back to the equation. This is our equation. You can see that the moles for hydrogen is 1. Or in short, hydrogen is balanced by what? 1. Magnesium is also balanced by what? By 1. So the moles of magnesium used in the reaction is the same as the moles of hydrogen. Reason? They are balanced by same number, which is a 1. So how many moles were required for magnesium? We said the required moles where is the answer for the required? The required moles were these. These were the required. These are the ones which were needed for the reaction. So we take these moles to be the same as for hydrogen. Reason, they are balanced by the same number in the equation. So we have volume of hydrogen at RTP equals the moles, which is 0.001 times 24 cubic decimeters. So we put more there per mole, so that this mole and this mole can cancel out to give us the volume. We now calculate 0.001 times 24 to give us 0.024. 0.024 cubic decimeter. Okay, this has been your tutor, Gus Madrid from Zambia. We call it a day.